There is a place in the universe where roughly 2,000 galaxies should exist. We have found about 60. Not 60 missing stars, not 60 missing planets, 60 galaxies in a volume so large that light needs 330 million years to cross it. If the Milky Way were inside that region, the night sky would not look like a sky. It would look abandoned. Most of the bright galaxies that help us understand where we are in the cosmic web would simply not be there. This is not a black hole. Nothing is swallowing the galaxies. There is no monster at the center, no event horizon, no object. That is the disturbing part. The thing missing from this region is not light, it is structure. The place is called the Bootes Void, and for more than 40 years, astronomers have had to live with a simple problem. The universe is allowed to have empty places, but this one is too large, too clean, and too close to ignore. The first unsettling thing about the Bootes Void is how it was found. No one went looking for a cosmic hole.
In 1981, 4 astronomers were doing something much less dramatic. Robert Kirshner, Augustus Oehmler, Paul Schechter, and Stephen Schechtman were measuring redshifts. In plain English, they were using the stretching of galaxy light to estimate distance, building a 3-dimensional map of where galaxies actually sit. If you only look at the sky as a flat picture, galaxies seem scattered everywhere. But once you measure distance, the universe turns into a map with depth. Some galaxies are close, some are far behind them, some are clustered together, some sit in long chains. The team expected irregularity. That was normal. They did not expect a wall of nothing. At one specific depth, in the direction of the constellation Bootes, the galaxies almost disappeared. Closer regions had galaxies, farther regions had galaxies. The slice in between had almost none. At first, that should sound like a mistake. Maybe the survey missed faint galaxies. Maybe the telescope was biased. Maybe the photographic catalogs were incomplete. Maybe the patch of sky was just poorly sampled. That is what makes the next part important. They checked. They expanded the survey. They looked at adjacent regions. They measured more redshifts, and the empty region did not go away. It became larger.
By the time the shape was mapped more clearly, the Bootes Void looked roughly spherical and enormous, about 330 million light-years across. Inside it, astronomers eventually cataloged a small population of galaxies, about 60 known objects, many arranged along a thin internal chain. So no, it is not truly empty. But that does not make it normal. For a region that size, a roughly average patch of universe should contain something like 2,000 galaxies. Bootes contains only a small fraction of that. The missing part is not subtle. It is not a rounding error. It is most of the expected universe.
This is where the story could become misleading, so we need to be precise. Cosmic voids are real. They are not rare. They are not a fringe idea. They are one of the main features of the universe. Galaxies do not fill space evenly. They gather into a cosmic web, bright filaments, dense clusters, and huge low-density cells between them. If you zoom out far enough, the universe looks less like a fog and more like foam. The bright walls and threads are where matter collected. The voids are where matter left. And that is the second unsettling thing about Bootes. The existence of a void is not the mystery. The scale is. In the standard picture, tiny density differences existed in the early universe. Regions with slightly more matter pulled in more matter over billions of years. Regions with slightly less matter lost more matter to their surroundings. Gravity slowly sharpened the contrast. That process builds the cosmic web. It also builds voids. So if someone treats the Bootes Void like a clean reason to throw the model out, they are going too far. Voids are expected. Simulations make them. Surveys find them. The universe is full of them. But expected does not mean every example is easy.
Most voids are smaller. Many are tens of millions of light years wide. Some reach hundreds of millions. Bootes sits near the upper end, large enough that it is not impossible, but uncomfortable enough that astronomers keep returning to it. That is the line this video lives on. Not impossible. Uncomfortable. Because the Bootes void does not just ask, why is there nothing here? It asks, how empty can the universe get before our model starts to sweat? Now, look inside the void. This is where the story gets stranger, because the galaxies inside Bootes are not scattered randomly like dust. Many of the known galaxies appear to sit along a loose chain, almost like a thin remnant filament running through the emptiness. That matters. If the Bootes void were one clean, empty bubble, it would be harder to explain. But if it is really a complex of smaller voids that merge together, with a faint leftover filament trapped inside, then it becomes less impossible. Still weird, but less impossible. This is one of the main ways scientists try to tame it. Maybe Bootes is not one giant hole. Maybe it is the place where several ordinary holes grew into each other. The problem is that even that explanation does not remove the feeling that something about our local universe is lumpy in a way we have not fully settled. Because Bootes is not the only large underdense region people argue about. There is also the KBC void, a proposed large underdensity much closer to us, possibly including the region around the Milky Way. That is not the Bootes void. They are different objects, and confusing them breaks the science. But together, they point at the same uncomfortable question. What if the universe near us is not perfectly average? That sounds small. It is not. Modern cosmology often assumes that on the largest scales, the universe smooths out. Not perfectly at every location, but statistically. Look far enough, and no direction should be special. No region should matter too much. The universe should become boring in a mathematically useful way. Voids challenge that intuition. Large voids challenge it more. And if we happen to live in or near a large underdensity, it could even affect how we interpret measurements of cosmic expansion. Low-density regions expand slightly differently because there is less matter slowing them down. This is why local voids sometimes appear in discussions around the Hubble tension, the disagreement between different measurements of how fast the universe is expanding. The Boats void is too distant to be the direct answer to that problem, but it is part of the same warning. The universe may look smooth from far away, while still hiding enormous unevenness in the places we can actually measure. And this is the final reason Boats matters. It is not scary because it destroys physics. It is scary because it does not. A broken theory would be easier. A broken theory gives you a clean villain. You say the model failed, throw it out, and build a new one. Bootes is worse than that. It mostly fits. It sits close enough to what we expect that no one can honestly say it breaks the standard model. But it also sits far enough out on the edge that no one can honestly call it ordinary. It is the kind of object that makes cosmology difficult, real, measured, confirmed, explainable in broad strokes, and still not fully satisfying. A place where the universe did something aloud, but did it at a scale that makes you check the math again. That is why the Bootes void is more than empty space. It is a stress test. A 330 million light-year question mark carved into the cosmic web. We know it is there. We know it is not truly empty. We know voids can form naturally. And still, when you point the map toward Bootes, the same fact remains. In a region where thousands of galaxies should have helped fill the universe, most of them are missing. The mystery is not whether the hole exists. It does. The mystery is why the universe made one this large here, and why our best model still has to squint to make it fit. Next video, there is one proposed answer to the question of why we have never detected another civilization in the galaxy. It is called the Great Filter, and the unsettling part is that we do not know whether it is behind us or still waiting ahead.